Yes, good afternoon, friends. Welcome to the session once again. We still have 1 more minute to go, so let's wait for some more learners to join in. After that, we will continue. I hope my audio and video is working fine. If you find my audio and video, if there is any problem, you can give me a feedback in the live chat box below. Okay? Yes. We'll wait for some more learners to join in. After that, we will continue. But as we wait for some more learners to join in, I have some important information to be shared from the Unacademy platform. That is, from Unacademy platform, introductory offer is being given for resolution to crack this UPSC Civil Service 2023. You will be getting an extra 10% discount, along with it 3 months free extension. With this, if you're 10% discount, you get around 70,998. But again, more discount if you use my code, that is educator code, that is SUNEP10. Okay, SUNEP10, you will get extra discount again. So the original price was 80,000, you can say 79,000. You will be getting by only 63,899. So you can use my code SUNEP10. The offer is valid till 12th of January. Along with this, you will get additional benefit, that is, you will get an access to a 20 GS book exclusively curated and designed for UPSC GS section or GS syllabus. Along with this, you will be able to attend a test series and also 3 months extension. Okay, so today is already 10th. You only have 2 more days to go, so you don't waste any time. Kindly subscribe to this. Next, your prelims for this year, that is 2022, is in the month of June, in the beginning of June itself. So taking this into consideration, the Unacademy platform has come up with this comprehensive batch courses on GS. It is also starting on 12th of this month. You can go for Mission 2022 or Expedition 2022. If in your roadmap, if you are planning to sit for 2023, still then you can go for Mission 2023 or Expedition 2023. Optional courses which are getting launched in the Unacademy platform this month is PSIR, Economics, Geography, History, Public Administration, Sociology, Philosophy. So if any of these subjects is one of your optional, you can kindly go ahead and subscribe to this to take the maximum benefit out of the course. Now, as you know, today we are conducting part 4 of Biogeography. Clear? In this particular series, we have already covered, we have already covered geomorphology, we have already covered climatology, we have already covered oceanography, so these 3 chapters we have already covered. Now we are discussing this biogeography. Biogeography, I will conduct 5 sessions. Today is the 4th one. Each session comprised of 40 minutes each. After finishing this, we will continue with environmental geography. Another 4 to 5 sessions. Clear? So in this particular biogeography, I was planning to finish the soil, important characteristics of soil and its distribution and the classification of the soil. After finishing this, I was planning to take up plants and animal, important characteristics, important conditions, climatic conditions, landforms on which plants and animals are distributed across the world. But I am afraid we are left with only one session, excluding today. We may not be able to cover this section, but don't worry. Under our oceanography section also, there are some important points which we have already left behind because of paucity of time. Therefore, all of these points, all of these topics which we are leaving behind, I will take up a special session after finishing our syllabus. Syllabus in a sense, till the complete syllabus as per the schedule. Okay, after finishing this, I give a personal guarantee that I will take up a special session to cover all the points that we are leaving behind. Okay, on the other hand, I have a plus course in Unacademy platform. Also, I have a special session in Unacademy platform where I discuss everything in detail. In YouTube, we have limitations. One is limitation of time. The other is the limitation of the tools which is available here. Here, the only mode of interaction is the live chat box below. But in Unacademy platform, you have this raise hand option also, where you can ask question verbally to me. Okay, verbally to me. So it is very interactive. Also, I have many tools in the Unacademy platform using which I am able to explain very, very efficiently. Okay, therefore, you can kindly come and join me in the Unacademy platform. Clear? With that basic introduction, let us begin our discussion today. We are discussing, in the last session we have discussed about factor responsible for the formation of soil. So the third factor responsible for the soil formation is the biotic factor. What is this biotic factor? The humus which is present in the soil. Okay. Firstly, the humus, the organic matter is supplied by plants or animals. Example, the plant give leaf. Okay, shed their leaf. The leaf becomes the source for this humus. On this particular leaf, it undergoes decay, decomposition, finally resulting in the formation of this humus. Now, important point is how this biotic factor influence in the soil formation is. The biotic factor give humus. On the other hand, you see here, it also, the presence of a biotic factor helps in the protection of the soil. The point is very simple. You see here, let me consider two areas. It is a very barren area where you don't have any vegetations on the ground surface. The second one is where you have a lush vegetations here over this particular area. Now you tell me, if there is a precipitation which is coming and hitting the ground surface like this, which area will be eroded more? Before that, tell me in which area surface runoff will be more. The surface runoff will be more in this barren area. Thereby, the more the surface runoff, the more erosion will result. But here in this, if you have a lush vegetations, what will happen is, you see here, whenever the precipitation is coming, the organic matter, or you can say the vegetations, intercept the incoming rain, does not allow the rain to fall on the ground surface directly, thereby protecting the soil. Second, after the water is intercepted, it is intercepted efficiently that the percolation is possible, therefore resulting in less runoff. When there is a less runoff, less erosion. Second, microorganism like bacteria as decomposers, algae as an early colonizers, early contribution to the organic matter in the soil, and are thus early initiator of carbon and nitrogen cycle. So the presence of this biotic factor in the form of microorganisms such as bacteria and algae performing different function. Bacteria as a decomposer, algae as a early colonizer. In our environmental geography section, we have already seen the ecological succession. If you are aware of this, well and good. If you are not, kindly go and refer to this. Ecological succession, in a sense, in a barren area. Say for example, if there is a volcanic matter, if there is a volcanic activity in one place, nearby surrounding this region, it will be a new volcanic landform which will develop. Now in this new landform, some organism has to go there and will have to modify the area in such a way. Other plants, other organisms, okay, come into this and create certain kind of ecosystem here. Now the first organism to go here is usually the algae. They are the early colonizer. And after this, different succession will take place, ecological, resulting in the climax community, which we have already discussed under our environmental geography. You kindly go and refer to that. Okay. But anyways, the point is very simple. The importance of biotic factor in the soil formation is, during this process of algae acting as early colonizer, it is modifying the soil condition also, thereby making possible for certain plant organisms or the grasses to grow. Thereby, step by step, a full-blown forest can be possible, or a horizon of a soil can be developed. Mesofauna, example, earthworms, ants, termite, that is the ingestion and the decomposition of mineral and organic matter, structure and chemical composition. Say for example, if I have an earthworm like this, it will intake the soil, say for example, because earthworm feed on mud soil. After its ingestion, it will be secreted out. The secreted out mud or soil will be different from what it has taken in, thereby modifying this. So the biotic factor and the nutrient cycle, recycling. Okay, so all of these factors are important. Then fourth, that is the topography. How topography influences the soil formation? The first one is the slope. Very simple. On a steep slope, the soil horizon will be less. On a plain area, soil horizon, that is the soil profile, that is the thickness of the soil, will be more. Exposure to the sun. The best example is regarding the Himalayan mountain ranges. Himalaya mountain run from west to east or east to west in this orientation. Here you will have this equator. Now the apparent shifting of the sun insolation is north to south like this. Now the southern side of the Himalaya always comes under sun insolation, whereas the northern side of the Himalaya is in a shadow area. Therefore, for the soil formation, we know you need this chemical reaction, chemical action. We have already taken the example. I have already shared the example with you regarding the limestone. Limestone is eroded very fast or weathered very fast in the equatorial region, where the temperature is high and also the moisture content is high. Whereas the same underlying rock, limestone, if it is put, or if you find this limestone in an arid and a semi-arid area where the temperature is still high but the moisture content is less, then this limestone rock act as a very resistant rock. Same limestone in different climatic conditions, and for this climatic condition, sun insolation is important. Therefore, here in the Himalaya, in the shadow zone, in the rain shadow area on the northern side of the Himalaya, since the sun insolation is always away from it, the region is always away from the sun insolation, the climatic conditions on the north of Himalaya will be different from the south of Himalaya. Therefore, depending on the climatic condition, the type of the soil will also be different. When the type of the soil is different, the type of the vegetation will also be different, so on and so forth. Clear? So this is the influence of, or the factor of, topography in the soil formation. The time factor, it is very difficult to generalize. Okay, the time factor, very difficult to generalize. Okay, why? Because you see here, the soil formation, suppose the thickness of a soil or some other characteristics of the soil, if you want to determine by looking at the time factor only, you see here, over a dense basalt flow. Okay, say for example, I have one area. Here I have a very dense basalt soil, rock, underlying rock. Now in this region, the soil formation means the thickness of the soil that will form will take a lot of time. Why? Because the weathering, erosion of this, resulting in the formation of the soil. So the thickness of the soil, it will take very long time in order to develop. Why? Because it is by the process of weathering. Weathering takes time. But on the other hand, on a glacial tilt like this, means glacial tilt in a sense, over a surface, we have this glacial, interglacial period. So during this glaciation and interglaciation, suppose if there is a melting of the ice. Now the ice, as we all know, carry a lot of sediments along with it. Now after the melting of the ice, the sediments left behind is known as glacial tilt. It is also a type of a soil, you can imagine. The sediments which is left behind after the melting of the ice. Now the thickness of this, now as far as the age is concerned, this may be much older as compared to this glacial tilt. But the thickness of the soil in this glacial tilt will be much thicker as compared to the thickness of the soil that is formed by the weathering of this dense basalt. Therefore, just by looking at the time factor, it is very difficult to assess. Clear? I hope that is clear. Now, these are the points that we have discussed so far. There are some important characteristics or the factors in the soil formation. Now let us quickly go to the next section, that is the classification of soil. In the world, if you go and see, the soil that you will find in different regions are different. And also there is certain pattern that is developed. Say for example, the soil that you will find in the equatorial region corresponds to the equatorial type of climatic conditions. There are other local factors also, but at least you have certain, in the equatorial region, depending on the climatic condition, you will have certain type of a soil. If you go to middle latitude, if you go to higher regions, that is the the polar regions, the tundra regions, the type of soil which you will find, they are different. Now the local conditions will be there. Say for example, even in the equatorial region, there will be certain mountainous area, certain plain area. So the soil formation in the plain area, in the mountainous region, in the same equatorial region, there may be certain local factors. Now, in a desert also, in the same subtropical high pressure area where you will have the tropical hot desert, in this also, one common type of a soil will form. That is, depending on the climatic condition of this particular high tropical, subtropical high pressure area, depending on the climatic condition. But here also there may be some local condition which will influence some small area. Say for example, in the desert you may have this water body, oasis. Now the soil development near this region may be influenced by these local conditions. So the local condition is there, but all in all, what we can conclude about the distribution of the soil on the earth's surface. One point that we can conclude is the soil distribution on the Earth's surface is zonal in characteristics. If I say a statement like the soil classification or the distribution of the soil in the Earth's surface is zonal in characteristics, which means if you go from equatorial region to the polar region, depending on the latitude. Now here, when I am talking about the latitude, I am talking about the climatic conditions. Why? Because the climate here also the same. The local factor is there. Okay, like say for example, in the equatorial region, the general climatic condition is very hot and humid. But even in the equatorial region, if you have a very tall mountain, on the peak of this tall mountain, it will be very cold. So the local condition is there. But all in all, when I talk about latitude here, I mean different latitude represents different climatic conditions, which means depending on the climatic conditions in different latitudes, the soil also is different depending on different climatic conditions, means latitude. That is zonal in nature. Understood? So when I am talking about the zonal characteristics, it means in different latitude, reflecting the different climatic conditions that you will find in different latitude, the soil also is distributed in the same manner. So that is based on the assumed origin and the observable properties that you can conclude. The second other important factor in the classification soil is the intrazonal soil. Okay, the intrazonal soil. The zonal soil is, I have just mentioned to you, they are well developed, their characteristics, and reflects the influence of the climate. The point which I have just discussed with you. That is, from the equator, if you go to both the polar, the climatic condition changes as per the different latitude. That is zonal. Depending on this, different type of soil is formed. And this type of soil that you will find based on different latitudes, you can say it is a zonal soil. Important characteristics is they are well developed. Intrazonal soil are some local factors are dominant. In a sense, the same example which I have just mentioned to you. In an equatorial region, you will have one climatic conditions, but in the equatorial region, if you have a mountain, you have certain local factors coming here. Similarly, in a desert conditions, if you have oasis, water body, then surrounding this region, because of this dominant local factor, the type of soil formation here will be different compared to the other general soil that you will find in the same latitude. Such a soil is known as intrazonal soil. Some local factor play dominant control, okay, other than the climatic condition of this particular zone. I hope this is clear. What is this azonal soil? Immature or poorly developed soil is known as azonal soil. Example, let me tell you. Azonal soil is a soil which is immature or poorly developed. Let me give you one example. Say for example, this is my hill. Okay, this is a hill slope. Now, from the hill or from the slope, the weathered material under the influence of the gravity will be fallen, will fell down, will be accumulated at the base like this. It is also known as regolith. Now, this is also a type of a soil. A soil formation can be here, but this soil formation is immature or poorly developed. Such type of soil is known as azonal soil. Others are newer alluvial soil can also be an azonal soil because the soils are not properly developed, they are immature. Clear? So as far as the classification of the soil, we are going to look at these three different types of soil. That is zonal soil, intrazonal soil, azonal soil. Remember here itself, zonal soil reflects the influence of climate. They are well developed soil. Then comes the intrazonal soil. Some local factor is dominant. I have already given you the example. And the third type is the azonal soil, that is immature or poorly developed soil. Clear? So this is one of the, these are some of the factors based on which we are going to classify the soil. but there are also certain criticisms to it, and the criticisms are zonal soil of one type can be found in the other. The second criticism is azonal, not necessarily reflection of time. The third one is the previous climate not reflecting the present. So, the first criticism is zonal soil of one type can be found in other. We have just discussed the classification of the soil based on the zonal characteristics. So, say for example in the equatorial region, since the zonal soil reflects the climatic condition, since in the equatorial region you will have only one type of climatic condition, that is the equatorial type of climatic condition. Therefore, all the soil that you will find in the equatorial region should reflect this climatic condition as per our classification of the soil. But in the equatorial region also, you will find different type of soil. Then how do you explain that phenomena if you are going for zonal classification? So that is one of the criticism. Another is azonal, not necessarily reflection of time. Okay. Chalo. Means you say immature or poorly developed does not mean that it has taken a very less, the time of development of this soil is very less or very young. See, even if sufficient amount of time has been elapsed, depending on other factors, a soil in some of the region, even after a very long period of time, may still remain immature and poorly developed because of some other factors. Okay. Now, anyways, with all those limitations, we will, despite of all of this limitation, we will try to classify the soil based on these zonal characteristics. The first type of soil is the tundra soil. Tundra soil. So, tundra soil distribution is you will find in the polar margin in the tundra region of the world. That is near this, just adjoining the polar region. That is the North Pole, South Pole. Clear? Now, what are the important characteristics of this soil? Remember this. Zonal type of soil, number 1, tundra soil, where you will find in the polar margins in the tundra region. Now, the figure, the diagram, the picture which is in front of you, okay, this is a tundra type of soil. Just by looking at the picture, what you can get out of this? Is it a well-developed soil or poorly developed soil? What will be the kind of fertility of this soil? What will be the content of humus in this soil? What is the texture of the soil? Will this particular soil will be cleat or sandy or loamy? We have discussed all of this. We have already seen the structure, the texture. Okay, so what type of soil will be this? We will see the important characteristics. In a tundra region, just south of this polar region, we all know it is very cold. When the temperature is very low, slow chemical and organic process will be there. Therefore, whenever you have slow chemical and organic processes, now peat is an accumulation of partially decayed vegetation or organic matter. The formation of this will take place. Little profile differentiation. This is because of soil moisture remains in the frozen state for greater part. Okay, little profile differentiation will be there. Why? Because you see here, even if it is a rocky or kind of this nature, not so far from the surface, beneath this, it will be a permafrost. All throughout the year, it is frozen. When it is frozen all throughout the year, you see, for the soil formation, you need weathering. For weathering, what you need? You need certain chemical action, chemical processes. Okay, physical processes, organic processes, which are very, very slow in this area. And also most of the time, just a few distance from the surface, beneath it is permafrost. So the soil horizon is very, very little, and also little soil profile differentiation you will find. Soil structure is angular and blocky. You see here. Regarding the soil structure, you kindly refer to that particular triangle, that is clay, silt and sand. You will know in this type of a condition or region, you will find soil structure to be angular and blocky. The soil texture is sandy clay, you see here, along with raw humus or peat due to the slow decomposition of organic matter and incomplete weathering. Clear? Waterlogging will result in poor aeration. I am not explaining anything more in detail. Why? Because we have seen everything very extensively regarding the soil ecosystem. Soil is not a passive agent. Soil is very, very dynamic. Soil exists in solid, liquid and gas. I have already mentioned to you. Okay, oxygenation, circulation, claying. Okay, what is clay? Okay, waterlogged conditions in a marshes region. We have discussed everything. Waterlogging results in the poor aeration. Why? Because the pore space is blocked, resulting in a poor oxidation, resulting in blue-gray color. That is the ferrous iron. All of these are important characteristics of this particular tundra soil. The second important type of zonal soil is potzols or potzols. Okay, now distribution, where you will find these potzols? You will find in a cool temperate with moderate to low rainfall and are closely associated with coniferous forests. That is just next to the tundra, that is just south of tundra, you will find this type of soil. In a very cool temperate with moderate to low rainfall and are closely associated with coniferous forests. What is the characteristics or nature of this coniferous forest? They are conical in shape, okay, right? Conical in shape, and the leaf is in the form of a needle. Why? Because it is very cold, okay. Therefore, and also the structure, it is all an adaptation mechanism that this particular plant has developed in order to survive in this harsh environmental condition. What is the characteristics of these potzols? They are heavily leached soil, slow bacterial decomposition. You see here, regarding this podzol, which is nothing but the pot S or Z podzolization or geluviation. We have already discussed this, different soil forming processes. Now, but anyway, for the sake of completing the characteristics, let me tell you, in this type of climatic conditions where you will find, or in this type of region where you will find this podzol soil, it is because the formation of this podzol soil is because it is heavily leached soil. Slow bacterial decomposition will happen because it is a very cool temperature region. Therefore, the surface layer of tough needles, that is the leaf of this coniferous forest, they are tough needles, takes a very long time to break down and produces organic acid, which is known as the chelating agent, which we have already seen. This chelating agent results in leaching of all the important bases or the materials from the soil, leaving behind silica rich soil in the surface. Therefore, such type of a soil is known as podzol or podzolization. Now, all the important bases or minerals such as aluminium, iron, they are leached below. Now, after leaching it below, where it will go? It will come down till the place where you have this parent rock, that is underlying rock. I'm not discussing anything further here. Why? Because we have already discussed the soil forming process and also the soil profile. Okay, now, this underlying rock, it may not be that much permeable or porous. Why? Because they may be usually a hard rock. Therefore, whatever the accumulation is happening, the water which is percolating down will remain here. And therefore, Iron botsol means iron aluminium oxide which was leached from the surface is deposited here. Why? Because the underlying rock may not be that much permeable or porous. Therefore, iron pane that is impeding the drainage means waterlogged condition will be here underneath in this type of a botsol soil, which you will find in cool temperate latitude. Okay. Now, because of this, you have this clay botsol. We have already seen what is clay. That is anaerobic condition where oxygen is less, water logging. So you will have this clay botsol. I hope that is clear. Productivity can be increased in this type of a soil by addition of lime and fertilizers. Clear? Now, grey and brown forest soil. Where you will find this type of a soil? The name of this soil is grey and brown forest soil. Where you will find distribution? You will find this grey and brown forest soil in the mid-latitude broadleaf deciduous forests. See, mid-latitude, okay. Cool temperate, now it is the mid-latitude. Where are the locations? Examples, the Western Europe, northeastern part of United States, North China, where more warm and moist conditions prevail than in the coniferous forest region. Now you see here, in the coniferous forest region, you have this botsol soil. Now when the temperature increases a little bit, that is you are coming further down south, and moisture also increases, then this type of a brown grey forest soil you will find. Area is south of this botsol soil, that is south of this coniferous forest you will have deciduous forests. What are the important characteristics of this grey and brown forest soil? They are less leached. Why? Because, why? You don't have this coniferous leaf, right? Now, coniferous leaf in the form of a needle. On the other hand, it is much warmer, so the chemical decomposition will be much faster. Okay, therefore, chelating agent, release of chelating agent is not here. Therefore, leaching is less. Clear? Now, therefore, the soil is less leached in this grey-brown forest soil. Because of this, they are less acidic. You see here, silica-rich soil. It is acidic in nature. Okay. Now, this soil, which is grey-brown forest soil, which is south of this deciduous forest, we are considering in the northern hemisphere, the tundra region, the coniferous region, where you will have this botsol soil. Just south of this, you have this grey-brown forest soil. Okay, they are less acidic and contain more humus. Why? Because more vegetations will be here. Vegetations will be much better here as compared to the coniferous, as far as the soil formation is concerned. Okay. Now, still leaching exists a little bit. Free calcium is absent but less acidic. Humus is well distributed in this region, and the presence of sesquoia oxide you will find. Okay. Sesquoia oxide is nothing but the oxide of iron and aluminium. Now comes the fourth type of soil, that is prairie earth. Distribution where you will find in the temperate grassland in the continental interior. You see here, it is in the mid latitude, broadleaf. Here it is the temperate grassland, means from this in the temperate middle latitude only if you go towards interior. Why? Because climatic condition changes if you go towards the interior. The basic idea of this continentality. Okay. Therefore, prairie earth you will find in the is a temperate grassland in continental interior. Moisture margins of area possessing Chernozem soil. Now you just forget about what is this Chernozem soil. It is in fact one of the most fertile soil, but we will discuss later. Okay, we are going step by step. But remember, in the moisture margin of this Chernozem, you will find this prairie earth, which is nothing but the transitional in character between pedicles and petal sphere. What is this pedagles and what is this pedals for? We have already seen in the last class. In the temperate, humid climate, you will find this prairie. Their important characteristics, that is the rainfall is sufficient, no pozzolic characteristics. Evaporation is not so high, so no lime accumulation. Nature of the rock, nature of the soil, that is dark brown, containing high humus. Soil having graded tapped, granular in nature, structure, neutral characteristics, means neither acidic nor basic. They are highly productive. They require less or little fertilization. Then comes the Chernozem soil. Clear? We'll end the session here today. We will continue tomorrow with this Chernozem soil. Okay? Anyways, thank you so much for your patience and cooperations. We will meet again tomorrow at the same time. Bye bye. Take care.